All right, we want to look at the seven graphs at the top of page 7 in your physics manuals. Graphing is very important for this class. We try to prove physics laws, and generally what that means is we eventually want to graph two variables against each other and figure out what the linear relationship is between them. So we have several variables that could be affecting each other. We keep everything constant except for one variable, which is called the dependent variable. That's x. And then we have the y variable, which is we have x is the independent variable, and then we have y, which is the dependent variable. So we change x over and over and over again, and then we see what the effect is on y, and we keep all the variables constant. So y is dependent on x. X is the independent variable. And we graph that. We just graph those two variables against each other, and we try to analyze the graph and try to see what kind of relationship there is between it. That's why we need to know like those 7 graphs, because you're going to always probably see one of those types of graphs. The thing we're really looking for is a linear graph. We want to figure out what is the linear relationship between these two variables. And so if it already just comes out to be a line, then that's great. We actually know what the relationship is, and we can actually print out what the equation is. The equation for a line, if you remember, is y equals mx plus b, where m is the slope and b is where it crosses the y-intercept. B is where it crosses the y-intercept, and m is the slope of the line. So the first 4 graphs are all this equation. That's the equation for all 4 of them. You're supposed to write the equation, the basic equation, on top of the graph or underneath the graph in your book. So, but we're not going to write this for all 4 of the first graphs. We're going to actually write the simplified version of this. So if you look at the very first graph, you have a straight line like this that looks like it's kind of going up at like a 45-degree angle. And assuming that the x and the y, that each of those are equal units, the x and the y, and a 45-degree angle does give you a slope of 1. And if it's going down through the y at the 0, 0, then this graph, the first graph, you would write as y equals, and the slope is 1, so you don't have to write it, x plus, since the y-intercept is 0, you wouldn't have to write that. So this is a y equals x. So your first one is a y equals x graph. That's what you'd have down for that. Okay, let's kind of just go ahead and get rid of all this stuff here. And let's do the next line. So the next line kind of looks like this. Okay, what would that be? Well, it's a line, so it'd be y equals, what's the slope? I don't know. It looks a little steeper than 1, so we'll just put in an m. So 1 equals mx, and plus a b. No, it'd actually be a minus a y-intercept, because the y-intercept is down here negative. Okay, so y equals mx minus b is what you'd write for that second graph. All right, the next one is going down like this. Looks like it's going down at a 45-degree angle, so it's y equals, the slope is negative, it's going downhill, so it'd be a negative x, and the y-intercept, it looks like it's still going through 0, 0, so it'd just be a y equals negative x. All right, and then the next one, it starts down here and it goes down like this. Okay, so that would be a y equals also a negative slope, m, x, and the y-intercept is also below the 0, so that'd be a minus b also. Okay, so those first 4 are all straight lines already, so that's good. Now, several times we'll come across the last 3 graphs, and we're going to do that in one of our labs here shortly, so we need to be able to recognize these. What if you graph y versus x? So you graph x and y. X is your independent, your y is dependent on your x, and you get a graph that looks like this. What is that? That is what we call an inverse graph. That means as your x went up, as your x goes up, what happens to your y? See, your y goes down as your x goes up. It's an inverse graph, and the way the relationship is y equals 1 over x. It's an inverse graph. You could write it as x equals 1 over y also. It doesn't really matter, okay? But that's an inverse graph. And every once in a while you're gonna see those, and you need to be able to recognize it, okay? So, well, I'll explain that here in a second. Okay, so the next one. We have it going like this. Okay. If you recognize this is a parabola, and this is a y is proportional to x squared. Y is proportional to x squared. Okay, so if you see that graph, that is probably how y and x are related. They're not just linear. Y would be proportional to the square of the x variable. Or you could do x is proportional to the square root of y. That would be the same thing, either way. And the last one that we have is the opposite. Oh, I lost my table, unfortunately, when I was scrolling through everything. So let me just put that back on here. Okay. So the last one is something that looks like this. It's kind of the opposite of the one we just had. So this one is y is proportional to the square root of the x. Remember, the one that went up like this was y is proportional to x squared. And you could have written that as x is proportional to the square root of y. So this one's going the other way, so y is proportional to the square root of x, or you could write it as y squared is proportional to x. So you just kind of got to look at those graphs, and you got to see how it all works out. Okay. Now, what we're going to do though is complicated. So every time we just graph x versus y. We graph x versus y. We throw it up on a graph, and we see what it comes out to be. And let's say that we do that, and it comes out to be this. Okay. So we say, hey, that looks like an inverse graph. That looks like that x is actually proportional to 1 over y, or y is proportional to 1 over x, not x proportional to y, but y proportional to 1 over x. And so we can prove that. And the way we prove it is we think the relationship looks like it's y equals 1 over x. So what we do is we take this x data here, and we make a new column, and we actually turn all this x data into 1 over x data. So we would do 1 divided by this first x, and we put it there, and 1 divided by the second x, and we put it there, and we'll let Google the Sheets do this for us. And then what we would graph is we'd have, like on our graph, so this is like y and this is x. But what we'd do is we'd regraph it, and we'd have y on here, and we'd have whatever this 1x column is for our x. We take all these, pretend like these are now our new x values, but they're 1 over x. And if we do that, and this was indeed an inverse relationship, it'll now be a linear line. It'll be a linear line. So if you recognize the relationship and you think, I think this is this kind of relationship, if you then graph that relationship, it'll end up being a straight line. Okay. This is complicated for people. So let's try it again. Let's do a different thing. Let's say that you graph y versus x. You have x and y, and you graph it, you throw it on a graph, and you see this. Okay, you might say, hey, that's not a linear line. That is y. It looks like that relationship is y is proportional to x squared. Okay, so what you want to do is you want to test it and see if it's actually true. So you make a new column called x squared, and you square, so all these x's here, you square them and you put them in this new column, and then you make a new graph, y versus, and you put x squared on the x-axis. So you're going to graph this column versus this column instead, and if it indeed was the correct relationship that you think it is, you're predicting, you again will get a straight line. You will get a straight line. Okay? So that's what we do in these graphing problems. We try to make it into a linear line. We try to regraph it until we get a linear line so we can figure out the linear relationship between two variables. If you didn't quite understand all that, that's okay. We're going to get lots of practice.